Hello everyone, welcome to another RISE application webinar. This is Neil Foley, Applications Engineer at RISE, and today I'm going to be talking about QR codes, what they can do, and how to use them with RISE. So the Quick Response Code, or QR code, is a simple pixel array that stores data and can be read by any smartphone with the proper QR code app. Similar to a barcode, QR codes harness two dimensions, giving them a much higher capacity of data storage. This capability can be very useful when applied to the surface of physical objects. A QR code can easily store information about versions, time and place of origin, and other metadata associated with a part. Information can be stored on QR codes in a variety of forms. Data can be stored as plain text, which is sufficient for basic annotation needs. Web addresses can also be stored in QR codes, allowing a code to link to anything online, including company websites, databases, images, and download links for any other variety of data types you could want. This function gives QR codes another powerful capability. While a fair bit of data can be embedded directly into a QR code in static form, by linking a QR code to a web address, it can access an effectively unlimited amount of data. Furthermore, the data being linked to can be changed dynamically, which is not possible for statically embedded codes. The main downsides of using dynamic QR codes is that they require an internet connection, and their data can be lost if the web host drops it, but this typically isn't an issue. The RISE 1 3D printer has a special combination of technologies that makes it possible to implement QR codes onto printed parts. The RISE 1 uses a hybrid printing system that jets functional inks between layers of FDM thermoplastics. This technology offers the ability to apply integrated markups to parts as they print. The marking capability can be used to print logos, annotations, or digital documentation in the form of barcodes or QR codes. There could be a large amount of information associated with a printed part, including part and version numbers, authors, dates, and printer of origin, as well as vital dimensions and their associated tolerances. All of this information could not reasonably be applied to the surface of a part using printed annotations, but with a QR code, all of this data and more could be applied to the surface of a part and accessed digitally. There are other benefits that QR codes offer that can't be achieved with typical printed annotations. By linking a QR code to a secure database on a web address with a gated login, any data stored on the part can only be accessed by those with access to the database. This allows parts to be annotated with classified or confidential information without handing that information over to anyone with the part in hand. QR codes can also be used for marketing or networking by embedding contact information in the code. This works like a business card attached to every part you print. Finally, QR codes can connect parts to their associated diagrams, instructions, and user manuals with much greater detail than printed annotations would allow. We're now going to view a brief video showing this process in action. Alright, so that's a lot of possibilities, but how are QR codes used? There are two programs involved in using QR codes. The first is a QR code generator. There are many generators available online with a variety of functions, but the main things to look out for are file types offered and unlimited use. Some image file types are preferable to others. PNG and bitmap files will retain maximum image quality, while JPEG files may lose data during compression and blur the lines of the QR code. Some QR code generators only allow a limited number of code generations before requiring a paid login. This first link for the QR code, or the QRCodeGenerator.com, has a very straightforward interface with unlimited code creation, and it allows you to save codes as PNGs. However, it doesn't include a built-in dynamic QR code option, so you'll have to use another site to host your data if you want to use that linking functionality. In the future, we plan to include a built-in QR code generator in RISE software that will allow you to skip this step. As for QR code readers, if you have an iPhone, you're all set because a QR code reader is built into your camera app. If you have Android or another phone, check the App Store for your phone to find a compatible app. The main differences among the various apps are just user interface related. Now, once you've created and saved a QR code image to your computer, you can import it into RISE software. RISE accepts 6 types of image files, including PNG and bitmap, so whichever file type you choose to save your QR codes, be sure that it is compatible. It is best to apply QR codes to flat top surfaces, so orient your model to allow this if possible. You can import your QR code image using the Markup to Picture button as shown in the image. This will open a file explorer where you can select your code and import it into RISE. Once in markup mode, you apply your code to the surface like any other markup, pressing apply once to verify and again to confirm. Now, QR codes offer a lot of power, but there are some things you'll need to pay attention to as well to ensure that they perform properly. One thing to be careful of is distortion of the code, which can happen when it's applied at an angle or onto a curved surface. The codes on the models shown in the images both became distorted due to angled application in one case and a curved surface in the other. These codes will be difficult to read. To avoid the problem of angled application, you can use the normal to pick option in markup mode. This lets you select a surface and the camera view will orient itself to face that surface directly. Another issue to avoid is obstruction of the QR code. The code shown in the model was applied to an inside surface using the Enable Front Clipping option. This will make it harder to read the code because it can only be viewed from an angle rather than straight on. For small obstructions, many QR codes actually include an error correction mechanism that allows them to scan even if a portion of their data is hidden or damaged, but it's best not to depend on this. Shown below is a QR code template that shows the digital structure of the code. Only the gray area can be partially obstructed. The rest must be visible for the code to scan. As for surface orientation, it's best to apply QR codes to top planar surfaces. If that isn't possible, vertical surfaces are the next best, followed by slanted, curved, and finally bottom surfaces. A top surface code should have pixels of at least 0.6 millimeters wide, and other surface orientations should be a bit larger. QR code readers convert scans to grayscale, making it difficult to scan codes when the background and foreground are similar shades, even if they're very different hues. This is why bottom surfaces don't scan well. The ink appears too pale to register on QR code readers. In some cases, a code that won't scan may succeed in different lighting if that lighting is able to increase the contrast between the blue ink and white surface. Finally, each QR code image includes a white boundary that helps scanners isolate the code from its surroundings. Don't put QR codes too close to an edge, as is shown in the model, because this could also prevent the code from scanning. Here is a specific use case of QR codes. In a prototyping situation where a part or assembly is going through many version iterations, applying QR codes to each printed part can help keep things straight. Using a QR code to link each part to its location in a database can help to track changes across versions of printed parts. For example, if you've printed several versions of a part where each version requires a different bolt size, then just by scanning the QR code, the linked database can tell you which hardware you'll need for each part. It can also tell you the relationships in an assembly among parts with different version numbers. This strategy allows a collection of printed parts of different version states to tell their own story rather than requiring you to reference and sort through an assembly tree for every part. Another benefit is that by linking to a database, the assembly relationships among the parts can be changed dynamically, or a part can be digitally obsoleted, and that information will appear to anyone who scans the printed model. Here is another use case for 3D printed QR code technology. For a variety of medical reasons, doctors will use MRIs and CAT scans to model the bones and other organs of their patients. Printing these models in 3D is useful for visualizing the problem during pre-surgery planning and can also enhance doctor-patient communication. QR codes can be a very useful tool in this case. A QR code applied to the surface of a printed model can link that model to a database of information about the patient, their medical condition, and the scan metadata of this particular model. But most importantly, that type of data is confidential, and it's important that just anyone with a printed model and QR code reader won't be able to access a patient's personal information. By storing that data in a linked QR code, it will be readily accessible, but only to those with permission to access the database. This application gives doctors a simple way to connect physical models to the associated digital information without risking confidentiality on their models. All right, that's all I have for you today. I'm here with Anthony Francis, the Customer Success Manager, and Julie Reese, the Vice President of Marketing. And we're going to open it up now for anyone who has questions or comments they'd like addressed. All right. One question is, why should you use QR codes instead of barcodes? So, barcodes can do a lot of similar things to what QR codes are able to do, but some of the benefits of QR codes over barcodes is that since QR codes work in 2 dimensions rather than 1, they have a lot more points of data to work with. So those 2 dimensions allow you to store a lot more information in a single code. Also, QR codes are called quick response codes because the idea is that the bullseyes and other features allow them to scan very quickly and quickly match up to your camera and transfer the information. All right, so another question is, what do you do if there are no good surfaces to apply the QR code to? This would also be in the case where you have a small part which just doesn't have a flat surface to work with. So unfortunately, QR codes, like anything else, are going to have limitations, and if your part it doesn't have any surface available that will accomplish what you need, then unfortunately you'll have to find some other way to document that data. All right, it looks like that's all we have for today. So as always, you can reach us at applications@rise3d.com.